Hi, this is Ratan Gupta from Knowledge Varsity, and in this video session I would be explaining to you about how the multiple regression can be done in Microsoft Excel. Okay, so we have a data set wherein we have the banking transactions. Okay, so you have account balance, the number of ATM transaction, whether the account holder has debit card, any other services he is using, and whether he receives interest in his account or not. In one of our video we have seen that the account balance is positively related with the number of ATM transaction. Okay, now I want to know whether this account balance is impacted by others or not. Okay, so typically if you try to see qualitatively over here, if the number of ATM transaction, okay, and has debit card, so note that if there is a debit card, usually the person would try not to do the ATM transaction. He would rather than paying through the debit card directly to the merchant. So you will find that there should be a, like, overall there should be negative relationship between the ATM transaction and the person having debit card. That we can see from the correlation analysis. But what is the impact of having debit card on the account balance? What is the impact of if you are using any other services on the account balance, and whether you are receiving interest or not on the account balance? So account balance is our dependent variable, and this ATM transaction, debit card, etc. are our independent variable. Let's say denoted by x1, x2, x3, x4, etc. Right? How do you find out this relationship? That we can do it through the data tab and then the data analysis. So if you press this data analysis, you will see the regression, and from there we can do it. So if you see over here this data analysis, we have to select regression. So data analysis, we have to select this regression, then press OK over here. Okay, right, and then it asks for the input range. Please note that the input range, they are saying input y range, that would be your dependent variable, and then they're asking the input x range. So input x range here will be your this values. So we'll see this input x range would be this. Here what I am saying is our account balance is dependent on number of ATM transaction, debit card, other services used, etc. Right? So there are 4 independent variables over here. Please note that once I have selected this value, it was B2 to B61. That means the first label was not selected, so I would not select this label, and I would bring the output in the new worksheet and press OK. So what we see over here is the summary output of the regression. So the regression summary output has come slightly better as 0.58. Compare that with a simple linear regression where it came as 50%. Here you get as 58%. That means there are other variables which are explaining apart from the number of ATM transaction on the account balance. Okay. However, in case of multiple regression, please note that R square is not a very valid factor, because of the interaction among the independent variables. It can happen that your R square value can be more, even though when there is no value added. So just think about is, you are saying that there is a relationship of x1 and let's say x2, okay, and then the x3. So even though it may happen that this x2 and x3 are not valid, because of the non-linear relationship among y with x2, x3, you find that R square increases. So in case of multiple regression, R square is not a valid factor for us. For multiple regression, the valid factor for us is adjusted R square. So we should rely on this adjusted R square and compare this adjusted R square with the case of only one variable. So we saw that in the case of only one variable, the adjusted R square was 0.5. So we say that okay, increasing the number of variable is giving us better picture, right? Then let us see the ANOVA analysis for this. Okay, so we'll go deeper into the ANOVA analysis and try to find out what exactly ANOVA analysis is bringing. So in this case, what we have is the regression. If you see, there are 4 independent variables. We know that this is k, the number of independent variables, the degree of freedom of that is k, and your residual is n minus k minus 1. The sample size is 60 minus 4 minus 1 gives you 55. total is n minus 1, that is 59. Sum of square regression, this is the value of sum of square regression. Mean sum of square regression is this. Okay, please note that the value of f is actually your mean sum of square regression by mean sum of square residual. So the regression value by residual values will give you, or instead of residual I can take as errors value. So looking at this data, it gives a significance value of f is very low. It means that this test is thinking from the f point of view, it is significant. Now what exactly I mean by significant or not significant? So in case of your regression, we normally do some hypothesis regarding the coefficient. So if you see this, the ANOVA table has also the description about the intercepts, etc. So let us see in this in detail over there. So the variable x1, x2, x3 and x4 are given. Their coefficients are given over there. So please note that intercept is also one of the output. So there are 5 outputs that we get. Each of them have their own standard error. The t statistics is given and the p value is given. Okay, please note that if you are doing a hypothesis testing at 95% confidence level, okay, then you should say that a variable output is significant if the p value is less than 0.05 or 5%. Okay, if the p value is greater than 5%, we say that intercept value is not significant, or that coefficient value is not significant. In this case, if you see over here our x variable, right, so x1, so what we will do is for x1 we'll do a hypothesis testing of h0, wherein we'll say that the null hypothesis is that x1 is equal to 0 versus alternative hypothesis that x1 is not equal to 0, right? And what we find over here is that the t statistics value is 7.26 and p value is very less. So if you assume that this as a t distribution, okay, we will say that there will be a interval created around 0. Okay, and we'll say that okay, if this crosses if the value that we are getting of the coefficient is outside this interval, then we'll say that we'll reject the null hypothesis. Otherwise if we are outside, we'll reject the null hypothesis. That means we'll accept this alternative hypothesis. Otherwise we will accept the null hypothesis. In this case, what happens is, okay, rather than creating the values, we will try to find out the t statistics value. So what is the t statistics value that we have? So here we can put the minus t value and here we can put the plus t value, and we can find out from this what would be whether the actual t value is greater than or this or not. So for finding out that t value, what we'll use is the degree of freedom, okay, and what probability we are interested in. So the probability in case of t, it can be 2 tail or 1 tail. So let us see how we can use that Excel. Please note that we are trying to find out these t critical values which are over here. Okay, if our value of the coefficient, if it is greater than that, we will say that we will reject. Here prima facie what we see is this p value is very less, so ideally we should reject this alternative hypothesis. Let us see what will be our t value. So if you see the t distribution, so it says that it returns the t distribution, but what are the values it takes? So it takes the value of x, okay, and then degree of freedom, and then whether it is a 2 tail or a 1 tail. So what is this x value? So if you see over here, let's say if I want to find out the 2 and degree of freedom for t is n minus 1, and the tail is, if I say 2 tail, okay, we say it's giving us 0.50 value, right? So here instead of finding out the t distribution, when we are interested, please note that when we are interested in finding out these values, okay, we will be not finding out the t distribution. T distribution will give us the probability for any value. Let's say for 2 value, it gave us the probability of 0.05 considering 2 tail. But I am not interested in finding out this. I am interested in finding out what is known as t inverse. So let us see what exactly is t inverse. Okay, so t inverse it returns the inverse of the t distribution. So here you have to say the probability, and we are doing with a probability of 5%. So here we'll say what is our probability of the testing. Our probability is 5%, and I am finding out what is the t inverse. Okay, so I will say t inverse. Okay, the probability is this, and the degree of freedom is, we have seen it is n minus 1, which is 59. So it gives us a value of 2.000. So what you can say is this 2.00009 and minus 2.00009, it implies that this value plus this value is 5%, or I can say that this is 2.5% and this is 2.5%. Right, so that means this value is 2.5%. Next is I have to see whether this is where it is standing. So if you see over here, we can see that it is standing somewhere around here 7, right, which is away from 2. So that means it is in this area. We can say that it is rejection of the null hypothesis. So rejection of the null hypothesis is what we can find out. So what we say is the null hypothesis was that whether x1 is equal to 0, and alternative hypothesis we had was x1 not equal to 0. So we will say that we will reject the null and we should go with alternative. So x1 is not equal to 0, and I can rely on this coefficient of the x1 over here. That is the idea, right? Now how do you get this p value? Please note that p value is actually the probability when this t is this. Okay, so if you want to find out, that actually can be find out from this t distribution. Okay, so t distribution, if you put this value, it will exactly it will be giving you, I think it's 1 tail if I see. Okay, it should give you this p value. P value is that probability of getting that value. So if you see over here, it's very less. In fact, I think it should be by 2, right? So similarly, what you have to now decide is, please note that this is the output that is given from the Excel, right? So you have to do the analysis and say that, okay, I want to do with 95% confidence whether I can say accept these values or not. So intercept I am not going to accept because its p value is 0.3. That means if I am doing a testing with 70%, I would accept this. So here I am not going to accept. This I am going to accept because it is very less. This I am not going to accept, 0.14. This I am going to accept because it is p is less than 3%. And this x variable 4, here he has missed the bus slightly because this is correct at 7.34, or it is correct at 1 minus 0.0734. So if you were doing the testing using 92.66% or lesser, I would have accepted this, but with 95% I should not accept. So what we say is only two variables are significant from this testing, and first is this x1 and another is x3, right? So these are the two variables which are significant, otherwise these other variables are not significant, right? So let us try to do the analysis on using only this x1 and x3. Over here what we have is, this is x1, so what we are saying is x2 is not valid here in this case. So let me just copy this data set over here. So and here I will delete this, and I will also delete this because I am saying that only the x1 and x3 were reliable. And then we do the data analysis, do the regression over here. Our input of the y range remains the same. Our input of the x range is now changed to this 2. Okay. And then see whether there is some values are coming better or not. Okay. So if you see the r square is coming 0.55. However, the adjusted r square has come as 0.53. Okay. So adjusted r square has come very less over here. So it means that this is actually the true r square that we are getting adjusted value, because the previous case the adjusted r square was higher. It was because of the non-linear interaction. So this is a better value of 0.53. Okay, and if you see over here, the f level is very much lesser, so that means this regression is correct. If you see the x1 variable, the p value is very less. The x2 variable, it is now 0.016. It means that we can rely on this value and this value of the regression, and we can say that okay, this is significant, this is significant. Now see the intercept p value has come closer. Okay, so 0.12. Okay, again this is not reliable. Okay, so we will say that intercept would be 0 over here. Okay, because here we'll do that hypothesis testing for intercept also, considering it 0 versus non-zero. So the null hypothesis is that it is 0 versus alternate not 0. So we will reject this. So we'll say that these are the only two significant value. But you can see that once we remove that x2 and x4 values, okay, here things have become much better as compared to the previous case, right? So this is like how you will use a multiple regression. Okay, using doing this data analysis is very simple, but what should be taken, what should not be taken is what makes a analysis better, right? And also please note that we suffer also from what is known as spurious correlation. It may happen that this x variable 2, which is the number of banking services, may not be useful, okay, over here, but typically we are saying that as higher numbers, because this coefficient is positive, we have seen that as this coefficient is positive, that means higher the services that you are using, more would be the account balance that you would be keeping with the firm. This can also be thought of from, let's say, if I try to create a scatter plot over here, we'll see that whether the scatter plot is coming as positive value or not. You typically see that some kind of positive relationship is there. There are outliers over here, but some type of positive relationship can be thought of over here, right? So please note that this is what is your output of the multiple regression. Your Excel is very much capable of doing the multiple regression, and you should use the Excel's multiple regression capability to get a understanding. Okay, and it's better that if you try to remove those items which are spurious over here. Okay, and note here, like what we have done is we have finally got these two as the variable, and we can write our equation. So if somebody says that what will be the equation over here, so I'll say that account balance is given as, I will remove this and I will say that it is 91.437 into the number of ATM transactions plus 67.8831 into number of services used. So this is the thing. Now what is the uses of this regression analysis? This uses of regression analysis, it can help you to identify those people with higher number of services they are using, so you can get a higher account balance. So it helps you in product positioning, identification of the proper clients, etc. In case of finance, it is useful in finding out what are the factors in which you can decompose your return and you can target those. Example is, let's say Sensex return would be dependent on GDP growth, inflation, interest rate, etc. So you can see what is the impact of each of these items. So multiple regression is very useful in marketing, finance, okay, healthcare, lots of thing you can use the multiple regression. Okay, so this was Ratan Gupta from Knowledge Varsity. I hope you liked the video and you understood the analysis of the multiple regression and how it is done in Excel. Thanks for watching it.